Hello, everyone. We are Beam Me Up. I'm Owen, and I'm joined here today by some of our team. This is Julian, and this is Austin. We'd like to tell you a little bit about our bridge replacement projects we decided to challenge ourselves with this semester. We were hired by McFarland Johnson to design a replacement bridge for a small brook crossing on Route 235 Hope Road in Lincolnville, Maine. We were also tasked with improving the vertical profile and the horizontal alignments of the roadway in the immediate area. This particular project was originally headed by Maine DOT and has been a thorn in their side for many years, so we're hoping we may be able to help them solve the problem. So what exactly is the problem then? Allow me to provide you some background of our site. This bridge is a single-span, 16-foot long reinforced concrete slab and was constructed 97 years ago. It goes without saying that a lot of construction standards have changed since then, and while it has stood strong in that time, we're starting to see some major signs of deterioration. Upon initial inspection, our team found multiple examples of exposed rebar and cracking under the deck, seen in these photos. We also noted that all the abutments have seen significant damage, as you can see in these photos. Mostly the wing walls have taken the brunt of the damage. They've lost whole bricks, and the walls have all been moved by the sediment in those 100 years. Something else that isn't visible by these pictures is that the abutments are actually restricting the flow of the stream underneath, and authorities on the matter are beginning to worry about erosion. Such as seen here, these photos were taken about 100 feet downstream of the bridge. These are the main areas of concern for the existing bridge, but the roadway above it also has caused a lot of issues. The vertical profile of the road has a large dip at the site of the bridge, so large that we actually calculated the sag curve of this dip to be 15. It should be no less than 64 in order to meet regulations. The horizontal alignment of the road has one main area of concern: the Hope Road, Moody Mountain Road intersection. In these pictures, I've highlighted the obstructed areas with red rectangles and the existing stop line with a red circle. The southern entrance of the intersection runs over a crest of a hill while also rounding a sharp corner. This, combined with overgrown vegetation, deteriorated pavement, and faded markings, result in poor visibility for drivers when entering from either side of the intersection. Also, it should be noted that the current design of the intersection encourages drivers entering from Moody Mountain Road to pull far off to the side, which makes it significantly harder to see oncoming traffic from the north side, as seen in these street photos taken by the team. The combination of all these safety hazards has resulted in a total of 12 recorded accidents occurring at the site since 2003. And in addition to that, our team here has personally witnessed 3 near-miss accidents during our first site visit and witnessed the evidence of a recent crash at our last site visit. Suffice to say, the site is in need of improvements. So I'm going to pass you to Julian, who will be able to tell you how we plan to fix these issues.
Thank you, Owen. Our primary design is a girder bridge. The girder bridge was designed in accordance with the AASHTO LRFD Bridge Design Specifications and the AISC Steel Construction Manual. Our girder design bridge increases the road height, helping to deal with the sag curve, as well as increases the span, giving cars more room on the bridge going around the curve. In addition, we designed the girder bridge as a composite bridge, meaning it has steel supports and a concrete decking rather than a CRC slab, as the concrete decking allows for increased moment capacity and stiffness, meaning more load can be applied on the bridge. The bridge will be supported by 4 steel girder supports with a concrete deck on top and concrete parapets. The total span is 20 feet and the width is 29 feet. As mentioned, the span and height are increased from the original design, helping to modernize the bridge while also staying within regulations. A huge advantage of this design option is the construction phasing of installation. The bridge can be designed and installed in 2 halves. Girder bridges are normally constructed by first building the substructure and then adding steel girders, pouring the concrete deck, and then finally adding parapets and guardrail. By doing construction in 2 phases, we will first construct the entire substructure, then install steel girders and pour concrete decking on one side. Once this is done, we can open up this half of the bridge, allowing for traffic to pass through a single lane. Construction on the unfinished side can continue while traffic is crossing on the finished side, reducing the need for a full detour. In conclusion, the girder bridge will help to improve safety across the bridge by increasing the potential traffic loads and increasing the span and height. It also provides a solution to detouring traffic while under construction, as one lane can remain open. Now turning to the roadway. Our new roadway design will increase the radius of the curve, increase the road height at the bridge by 2 feet, and improve intersection design, allowing for increased car safety going across the bridge and around the curve. Here's the current roadway alignment seen on the left. along with our intended changes to the roadway alignment seen on the right. The right picture shows how we plan to change the shape of the roadway. We have increased the radius of the curve north of the bridge to help make the turn easier on drivers. Below is a graphic detailing our current sag crest with the proposed 2 feet of added elevation. This increase in height will help bring our road closer to AASHTO standards. Now on to the intersection. The current striping currently just has a stop line on Moody Mountain Road and no center line. Our design pulls the stop line back and increases the length, causing it to span the whole lane. This change increases stopping sight distance while also adding a left and right turn arrow before the line, indicating to drivers that there is only one lane to turn from. We will also be adding a double yellow line at the intersection, extending 600 feet back to better outline the intersection so drivers can see exactly where they are turning into. Finally, we will be making improvements to the signage along the roadway. We'll be adding these 2 signs leading up to the intersection on either end to help show drivers there's a steep curve ahead and they need to reduce their speed. We will also be lowering the posted speed limit sign to 25 miles per hour instead of 40 miles per hour to reduce drivers' speed heading around the intersection. This curve warning sign, in addition to lowering the speed limit and adding a speed monitoring sign, should signal to drivers that there is a curve approaching and they need to slow down to the new speed limit of 25 miles per hour. The main goal of our roadway redesign was to improve the sight distances and overall safety of the roadway, and we believe if implemented, these changes will do exactly that. Now, I will let Austin talk to you about our internal and external project constraints.
Thank you, Julian. As Julian mentioned, we increased the curve on Hope Road. We had to be careful because of the constraints on either side of our project. On both sides of the road, we had private property and wetlands. If we tried to push the curve any further, we would have started impacting those areas. That would mean more permitting, higher costs, and potential issues with private property. So instead, we adjusted the alignment and essentially sandwiched the roadway between the property lines and the wetlands. That allowed us to improve the curve while still staying within the limits of the site. Another big constraint was constructability. Because of how narrow the corridor is and the size of the existing structure, construction would likely require at least some level of road closure. So we had to consider designs that were practical to build and help reduce how long the roadway would be impacted. The girder bridge is a good compromise to these constraints. It allows for at least one lane to be open for the majority of the construction phase-in. Budget was also a major factor. We were limited to about $2.5 million, which influenced how much we could modify the roadway. For example, there's an existing dip in the road that doesn't fully meet visibility standards. Fixing that completely would require us raising the road a significant amount. That would expand the footprint, increase the earthwork, and push us over budget. Because of that, we focused on improving the curve as much as possible within the space we had while keeping the project realistic. In addition to site limitations, we also had internal project constraints that influenced how we could refine our design. One of the biggest challenges was scheduling. With different commitments across the team, coordination time was limited, which meant portions of the design were developed independently and then combined later. While this allowed progress to continue, it also limited opportunities for full team interaction on every part of the design. Resources were another constraint. We did not have access to complete existing plans or detailed site information, which would have been available if this was a real project. So assumptions were required. Because of that, our design focused on realistic improvements that could be supported by the available information rather than pushing into areas that would require more detailed analysis. Our experience level also influenced the refinement of our design. While the team had a solid understanding of roadway design principles, some aspects required a learning curve, and that meant prioritizing the most impactful improvements first. This is reflected in areas where the design improves safety and geometry, but does not attempt to fully reconstruct the entire corridor. Time was our last major factor. With a single semester to move from concepts to final designs, we focused on developing a practical and constructible solution. This meant prioritizing feasible and reliable over pursuing additional refinements that would require significantly more analysis. Taking all these constraints into account, from site limitations, constructability, budget, scheduling, and then available resources, we believe this design provides a strong balance between improving the roadway safety, maintaining a feasible budgetable project, the alignment improves the curve as much as possible within the corridor while minimizing impacts and keeping construction practical. Overall, we believe this design is a realistic and effective solution for our site. Thank you.